So, yeah.
Yeah, one other issue, and this is a bit more of my just general scientific curiosity, is I'm interested in sort of like study of one type things, where essentially, which could include something as simple as people experimenting on themselves, or things like dietary and exercising habits, and which I know on one side gets sort of derided as anecdote, on the other side, it's effectively personalized experimentation, which I would say is probably the most valid thing that you might have, given that you're usually only trying to optimize yourself. Um, but I was wondering about sort of experiment of one type work for this, where effectively when you have an injured athlete and you're trying to optimize a recovery regime, it's a little bit of a one shot process, where you only have this one person at the time. And well, yes, you could say on average these regimes do better, or these regimes do worse across a cohort. Um, how much? This is a mushy
Yeah.
question, but basically, what are your thoughts on those types of things? Um,
Yeah, I mean, I think you're right. And, personalized modeling is really kind of the biggest thing we're going to want to do. So, yeah, I think that that's definitely one of the goals of ours, because we would love to, like you said, have an athlete come in and get them up to where they need to be. I don't think we're not personally there yet, but we have started to look into that. I think, that's a changing idea with the field. I think a lot of times our field wants to do these big cohort studies, and that's what they like to see. But like you said, there is kind of this importance in being able to say a lot of this needs to be tailored to the individual, and that's kind of the where they're going. So I think that transition is coming. We're not there yet. But we do, like I said, we have collected some data on some interesting individuals that we do think we can put out kind of papers on, where they have some kind of very unique unique ailments, so to speak. But yeah, I don't think our field, I can't speak for everyone, but I don't think our field is there yet. But I definitely think that that's where we're headed, we're going. And that's really important. Yeah.
yeah, that is an interesting thing. When you talk about unique ailments, because as you might know from some of the oncology research, there are some very weird genetic activities out there, and both from the perspective of patients and the heterogeneity of cancer tumors. And I very much respect the fact that in a lot of oncology work they actually do have a publication space for these sort of new N of one discoveries, and they can be things like a typical one might be when an especially young person gets a some type of leukemia that's only usually exhibited in people 70 and older, and then the question becomes like, oh well, was there like some like consanguineous aspect of this that has vastly upped their risk and things like that, and there's a place in the research for that and allows for discovery. And um, I'm heartened to hear that your field is also interested in sort of these odder dynamics and things like that. So if someone comes in and they're especially messed up physically, so to say, that there would be a place where they say, okay, here's this particularly odd patient. Let's discover what their mechanisms did. Because I think that brings us back into the realm of scientific discovery. And I think that a lot of the times when people do these more like battle the algorithms, what can have that has the best predictive ability, that they forget that they're actually trying to discover things about the real world. Um, yeah.
Oh yeah, and I didn't pick up, but yeah, 100%. And like you said, you highlight that it's very important that's what we're doing. And so yeah, and the nature of the nature of scientific discovery, I think we do need to do more of that. So I think we're getting there. And and I even think about and kind of maybe dovetailing into some of the other arena. I think what some of these other groups that have probably been around longer, who've done cancer research, I think they've done a lot better job of making data sets publicly available and getting out there. Because like you said, when you wanted to do these kind of machine learning algorithms, say, here's this data set, who can generate the best one. I think that other groups, that leads to, I think that there's a camaraderie in that we're all trying to solve this together. And I think that does talk about the availability of data sets and identifying these unique things. So yeah, I think our group is getting there. I just think it's kind of being young, that we're not there yet. But I know there's some work, I think, out by Stanford by Scott Delp, where they're trying to develop these larger databases that we can all use for biomechanics databases, so that we can make some of these bigger strides in these scientific discoveries. Yeah.
So sort of like a biobank, but for physiological gait injury and things like that.
Yeah, that would be huge. Because I mean, I think, and me struggling from the fact that, struggling to even get these clinical partnerships, it would be great just to have that data. I would just, to sort through. So yeah, I think a biobank for biomechanics would be ideal.
Mhm.